Welcome everyone to this OSGi track with Dirk Fout from Bosch here in Stuttgart. And Dirk is going to tell us or teach us about how to use declarative services in OSGi.
Thank you, David. So hello everybody. Well, it seems that most of the people at EclipseCon know about DS already. So I suppose the people here are not aware of DS. Is that true? Okay, then. All right. Anyhow, it's a getting started about OSGi Declarative Services. Just to introduce myself in short, my name's Dirk Fout. I'm a research engineer at Bosch, and I'm an Eclipse platform committer. And for people that do not believe that this is me on the picture, I made my my perfect PowerPoint and slides. So yes, it's me. Yeah, really. Okay. Well, let's start. I have plenty of slides because that topic is quite big, even easy. It's big. So let's start with this picture. You might have seen this before, and it's inverted from the spec. David, if you notice this. Oh, sorry. Need to. So we have a bundle A that is a service provider. So it registers a service somewhere. Now we have this service in a global service registry. And we have a bundle B that wants to find a bundle, find a service, and then get it to consume it. That's a pretty simple picture about this. And that's how services in general are working. So that's nothing pretty big or interesting. Yeah, we have this publish, find, bind. So we publish something, we find it, and then we bind to it. If we're talking about declarative services, I want to start with some names. Because first of all, when you're working with DS, you're not talking about a service in first place, you're talking about a component. Yeah, so we have a component, and it's a service component because most of the components you're writing are services, but I'm coming to this later. And a component is typically a Java class contained in a bundle, and it's declared via a component description. A component description is an XML document that declares the service component. Nothing pretty big. We have a component configuration, so you can parameterize and configure your component. So you can have different instances with different configurations, change the runtime behavior if it's implemented this way. And it tracks the dependencies and manages the component instance in the whole runtime. And the component instance, well, yeah, it's the instance of the class, of your component class. It's created when the component configuration is activated. And it's discarded when the configuration is deactivated. So far for the names on the component itself. And then we have references. So a reference is a dependency to another service. And this term really a service. Target services is what you define as the service that you want to reference. So this is your target, the reference interface that you want to reference. And you have the bound service, so this is what you then really have put together. We come to this in a few moments. And to access services or to access references, there are different access strategies. In previous specs until R7, so in R6 you will find the name strategy. So there is an event strategy, a field strategy, and the lookup strategy. With R7, this was renamed, probably to be more concise about what it really is. So we have method injection. So you can inject services in a method. You can have the field injection. So you get services injected to fields. And since DS 1.4, we also have constructor injection. So I will show this. And now with these names, it's also more similar to a CDI spec or other technologies in the Java world out there. The lookup strategy is still named strategy because it's not an injection, but I will show you this too. So this is still named lookup strategy. Then we have basically three component types. We have delayed components. So these components are activated when they are requested as a service. And they need to specify a service. So a delayed component is always a service. We have an immediate component. They are rare in use. They don't need to specify a service. And they are activated as soon as all the dependencies are fulfilled. So when everything is satisfied, this component gets activated. That's a special case. Typically, for example, on an application startup, similar to a main class. And we have a factory component, so it creates and activates component configurations on demand. To be honest, also factory components I have seen in the past rarely. But there are use cases, definitely, otherwise it would not exist, but I have seen them rarely. For the life cycle, you can see for the immediate component, when the bundle starts, it loads the component definition, the component XML. Then whether it's enabled or not, you can even specify that a component should not be enabled by default and do this programmatically at runtime, but typically they are enabled. It's in an unsatisfied state, and when it becomes satisfied, that means all references are resolved and can be set. It gets activated. It's then in the active state, dependent on several constraints, whether referenced services are dynamic or static. It becomes unsatisfied and deactivated, and then reactivate once it's satisfied again. That's immediate component. The delayed component is different in terms of even if it becomes satisfied, it's not automatically activated. It's then in the registered state. So the service registry will tell you this service is registered and ready. And then it needs to be activated, and this happens when someone wants to use this service. This brings a big performance boost on startup because not every service is directly started and available from the beginning of your application. So application startup really benefits from this process. Also here we have the active state, so it stays active until everything is until everything is satisfied. If something becomes unsatisfied, then it will deactivate again and return back into this unsatisfied state, and can also be brought back into the registered and active state. Okay, activation, as you can see, for the delayed components is a big topic, as it's really also for startup performance and everything. And activation consists of the steps that we are loading the implementation class. We have dynamic class loading in OSGi, so this is an important thing. So the class itself is, the implementation class is not loaded until it's activated. The creation of the instance and the component context, they are created at activation time, not before. Also binding the target services. So even the service component runtime knows we can satisfy everything because the services are existing. The binding happens on activation, not before. And then there's an activate method that's called if this activate method is present. I'm showing the nice thing on this activate method shortly. So the consensus here is for delayed components, the load time is moved to the first request, including the reference bindings. So compared to an activator in bundles that you should not use, don't do this, or extension points in Eclipse, stuff like that, we really have all these loading operations at request time and not in advance. So typically we are benefiting from this process in the startup time. Just for sake of completeness, a factory is, well, the factory itself is a kind of component, yeah? So it's unsatisfied, it becomes satisfied when all references are set, and then we have this factory, and the factory is then creating new instances. They are activated, registered, and once they are done, they are disposed and removed. So the service instances that are created from the factory. But I don't want to get further on the factory stuff. It's kind of special, and we're in the getting started. How to implement? The first thing you're doing when you're creating a service is you're creating an API bundle and defining the interface. That's a very simple one. In another presentation, I called this even the most stupid service ever, because it's a public interface, it's a string modifier, it has one method, modify, it gets an input and returns another input. That's pretty simple, but I like such simple things to explain and understand mechanisms in the back. So you have this service interface. The main thing why we are creating the interface in a separate bundle is that we are making the service implementation exchangeable. If we have the service implementation and the interface in the same bundle, how do you want to replace that implementation? That's not possible. And you have a clean dependency hierarchy. For this, I have made my tremendous PowerPoint skills in animation here. So let's assume we have this error handler bundle, and we have the interface error handler, and we have a service implementation error handler impl. Now this error handler impl has a dependency to SWT because we wanted to show a dialog if an error happens in my Eclipse IDE. That means I have a transitive dependency from the consumer bundle to SWT. I know there are mechanisms inside OSGi that you can hide this without the exporting and stuff, but at build time you have this dependency. But I probably don't want this. If you change this and strip interface and implementation, now this cool animation, you have this picture. So the consumer only knows the error handler API without any transitive dependency. And the implementation has a dependency to SWT. And now you're free to use your error handler in any scenario. That's the main thing here. So that's why we are separating an interface and the implementation. There are cases also in the documentation where you see that things are bundled together in one bundle. But for clean architecture, this should be the case. How do you create this? I have to admit that I switched the slides here to use BND tools instead of Eclipse PDE, mainly because Eclipse PDE does not support DS 1.4. We can use it until DS 1.3. The newest versions of Eclipse also contain DS 1.4, so the newest Felix SCR implementation is part of the Eclipse IDE, Eclipse framework. But the tooling does not support DS 1.4. That's a pity, and unfortunately the maintainer has told me that he does not have the time to fix this in PDE. So just in short, if you're using PDE, you are adding you have such a BND file, you describe the OSGi metadata. So here in the build section, you're adding, no, here you don't need to add anything. You just specify what you're exporting because it's the API bundle. We're only exporting things and we don't have dependencies. Who knows BND tools? Okay, most of the people don't know BND tools. Okay, BND tools is the OSGi tooling for OSGi development. For Eclipse, PDE was the OSGi tooling and still is, but it doesn't evolve anymore. BND tools is pretty active. And one bad thing about PDE, from my point of view, is that you have to write the manifest file in the correct way yourself, because the manifest file is the heart of an OSGi bundle. Because you need to write this, the people from PDE made things easier for developers and introduced bad things, like require bundle, avoiding the naming of versions and version ranges, avoiding semantic versioning the correct way. So you can skip this all if you're writing your Eclipse application, because you're actually not that dynamic at runtime. Now, B&D Tools also knows that this is hard to write the manifest file the correct way. So they have provided this tooling where you actually are doing the same thing with PDE. So you just say, where are my dependencies? And the creation of the manifest file the correct way is done by B&D Tools in the back. So you don't have to worry about these constraints to be a good OSGi citizen. Just as an introduction to B&D, a short introduction to B&D Tools. It's far more powerful, but that would extend this session. The service provider, on the other hand, well, we have the service provider bundle, and we provide the implementation. So we have a string inverter that implements string modifier, and we have this very simple Java code here that reverses the given string and returns it, yeah? So the important thing here is this small annotation, add component. That's why I also introduced with, we are talking about components and not about services, because then it's easier to remind there's the add component annotation. And the add component annotation is actually responsible for creating the component definition XML for you. We don't want to write XML files. We need to do this in the past, but with the introduction of the DS annotations, we don't have to do this. The tooling is doing this for us, and we are telling the tooling it should do this for this class because of the small annotation. And that's it. So for the bundle itself, well, yes, you have to add to the build path the API bundle, so the resolving is working correctly in your bundle path. And you're adding the package to the private packages because we don't want to expose the implementation of our service to the outer world. We just want to expose the interface. This is also an important thing here, that we really encapsulate. We are working against interfaces in the modular world. We are not working against the implementation. So add component marks a Java class as a service component. In this case, it's service component. Yeah, it generates the XML file, and it puts additional headers in the manifest file, like the service component header, the provide capability, and the require capability for OSGi Extender that was added with DS 1.3. Who of you know about capabilities? Okay. Just for the record, only 2. Short excursus on capabilities. You all know about import package, export package, and require bundle, right? Yes, okay. So this is the way you are creating bundle dependencies on a technical level. With capabilities, you're also able to create dependencies on a functional level. So it's a non-code dependency, and for OSGi Extender, it means we require the capability of the service component runtime with this small snippet. Why do we need this? Because we want to start up the service component runtime, and we also want to specify in the dependency that we need the service component runtime. But we are never touching any class from this runtime. So how do we tell then that we have this dependency? And we are telling this via the require capability header. The same applies, for example, for the event admin, because we're talking about talking to the interface or we're getting things injected. We're never touching any single class from that bundle, and we want to still specify the dependency. So this is what capabilities are. Yes, this OSGi Extender, it was added to the spec with DS 1.3. Equinox DS adapted this with 4DS 1.2 in Eclipse Neon. Basically, I think even I was a person that requested this back then, but Equinox DS is dead. Eclipse itself is now using Felix SCR, so we are pretty clean in this. I just wanted to mention for people that are using older versions of Eclipse still. And here we have, we also can provide the capability, namely the OSGi service. So we can tell in our bundle that we are providing an implementation for the string inverter. And then we can also specify a functional dependency with regards to this on a service level and not on a technical package level. Back to add component. I have mentioned here all the properties that you can add to add component, and I mentioned here the default values. Just for reference, I don't want to go to everything or through everything. Mainly, you can here, for example, with enabled, it's enabled by default true, but you can also say I have here a component that should not be enabled by default and I want to enable it on the way. You can specify then it should be immediate. So then you have the immediate and not a delayed component. You can specify properties for configuration purposes. That becomes interesting for the S1.4 in short. Yeah, in 1.3, reference and scope was added, so you can control how many instances of your service are available. And in 1.4, the factory properties were introduced, so you can even configure your component factory via properties now. The next annotations I want to show are the lifecycle annotations. Add activate, add modified, and add deactivate. These are the component lifecycle, or before 1.4, they were solely used on component lifecycle methods, like the one here, the activate method. So add activate is called at activation time of your component. It has some method parameters. Today they are called activation objects. I'm not sure if they were called activation objects before, but in R7 they are called this way. And they are categorized, it's these four values you can have: the component context, the bundle context, a map containing the component properties, or a component property type, which was introduced in DS 1.3. Component property type, do I have this? I'm not sure. It's an annotation. A custom annotation with your properties that's type safe. Because as you can see, the map here is a map of string to object. So we don't know what's in that map actually. With a component property type, you're becoming type safe. And you can specify default values. Additionally, for the deactivate method, there's the integer parameter. So you get the reason why a component was deactivated that you can evaluate. And since DS 1.4 add activate can also be used on fields, and if you use it on a field, you can get the activation objects injected. Before, with versions before DS 1.4, you need the activate method to get the bundle context, component context. With DS 1.4, you can have them in a field and get them injected automatically. And you can have it on constructors. This is what I'm showing shortly. Service consumer. Yeah, now we have the service interface. We have the service itself. Now we want to consume it. So here I'm using here a go shell command to consume my modifier, my string modifier. At top you see the definition of the property. The properties, so these are needed. This command is registered on the go shell, so I can type a console command to trigger this implementation here. And we have the add reference. Yeah, and then at the bottom you see if someone calls modify, then we are printing out to the console the result of the modifier. Pretty simple one. Important thing here is add reference, because with add reference we are specifying the dependency to the service that we want to consume. So here it's written, you specify the dependency on other services. Resolving these references is mandatory to satisfy the component. So if the service that I want to consume is not there, my service, the consumer, is not started, not activated. But you can also configure this to be optional. Then you need to deal with null references and so on. Here, well, that's a repetition of the different service access strategies. And how's the time? Oh, okay. I'll get that. Okay. Then let's start. Method injection. For method injection, that was the first or was one of the starts in DS. We have event methods, bind, updated, and unbind. These are the default values. You can override them. But it actually means here you are annotating a method with add reference that is getting my service. And this is called once the service is available and we bind. You can also have it updated if you work with configurations. So if the configuration changes at runtime. The updated method is called, and unbind is called well, when the service goes away. For example, the bundle is uninstalled, stopped, whatever. The provider is stopped. Most of the time it looked like this. So most of the declarative services pre 1.3 were looking like this. So I'm setting it to a instance field, and I'm setting it to null when it goes away. Pretty nasty. That's a lot of bloat code. With DS 1.3, first, the event method parameters are the service reference, the service type, or a service type plus the properties. And with DS 1.3, you can have component service objects and different variations of these lists. Pre 1.3 this was kind of limited. But let's go on with the next one. Since 1.3, we have field injection. So compared to the previous version, here with these three methods, we now add reference over the field. So we have a field injection like we know it from other CDI frameworks. Pretty simple one. Since DS 1.4, we have constructor injection as well. But in that case, we don't use add reference. For constructor injection, we need to use add activate because it's an activation process. Such an instance is only created once, so we need to use add activate. And add reference you're using on the method parameter to tell the service component runtime that I'm requesting a service. And you also need to notice that such a reference is not dynamic. So it cannot come and go at runtime because a constructor is only called once. So it has to be a static reference. Not correct?
If it's dynamic, the config goes away, the object is destructed and recreated.
But then it's a static reference.
Yes, it's basically you get a new object.
Yeah, okay. Sorry, I didn't mention this before. References can be dynamic, so the instance stays while a referenced service comes and goes. That's then called a dynamic reference. A static reference means if my referenced service goes, my consumer is discarded, and if it comes again, a new consumer is created. So this is the difference. You can configure how you want to have this service reference, but that's on 2 slides. Anyhow, constructor injection DS 1.4. Now, lookup strategy. That's something special and probably something from the very early beginnings of declarative services. What it actually means is that a referenced service is looked up when I need it. So I said before, if you have these field injections, or you need to satisfy your component, the services need to be there. This can create performance issues if you have a long chain of dependencies. So service A references B, B service C, C, D, and so on. So you have this long chain, and if you have this and just activate the first service, a lot of things are happening. If this is the case and you want to reduce the startup time, you could do a lookup. And then you only have the service reference here as a field. And once you need it, you look it up in the service registry. As you can see, this is quite some code for DS 1.2. This was improved with DS 1.3, where you have add reference here in the component annotation as a parameter, and the component context got a new method, locate service. So this was a nice improvement to reduce the code on DS 1.3. And with DS 1.4, you can even reduce 2 lines more, because we have the field injection of activation objects. So if you want to use the lookup strategy with DS 1.4, it's quite as simple as using a field injection. Only the add reference in the add component definition is there. Add reference has also several parameters. Like before, I added the only the default values, so you can have a cardinality. That's a pretty important one, because you can say I only have one mandatory, optional, 0 or 1, or you can have a collection, at least one or any. Yeah, that's pretty important. Name is not that important. Here the policy, that's pretty important one. Like I said before, by default it's static, so when it goes, my consumer goes. You can change this to dynamic, then my consumer instance stays. For example, if the activation is heavy, you would choose this way. Target filters, bind, it's on the field, and since 1.4 you also, I have to admit that I did still not understand the parameter value. I tried to read it, but I have not found an example and what it does. And collection type, it's, yeah, what type of collection? Did I wrote? No, I forgot to mention this. But, yeah. Component property types, I need to hurry. Component property types are annotations. So this is a component property type. So I'm specifying the type. Gogo command, it's an annotation. It has 2 parameters, and I'm specifying a default. What is important for DS 1.4? The important thing is that pre-DS 1.4, you need to write component properties this way. So for my gogo command, I had to specify OSGi command scope and function in this string manner. Now with DS 1.4, I can even use this component property type and specify it as an annotation on my component. So I have this annotation style development like you have it in Spring or JE or something like that. And additional goodies with DS 1.4, we have 4 standard component property types for some default or standard properties like service description, service ranking, vendor, and exported service. And you can inject an OSGi logger of the R7 spec to show this in short. So here you can say my service has a service ranking of 10 with this annotation, so you don't have to specify this string property anymore. Service ranking means you can specify if a service with a higher ranking is coming up at runtime, it should be replaced for a dynamic component, for example. So you could control this at runtime. And well, this is a special injection, as you can see, because I'm getting a logger but I'm requesting the service logger factory. That's kind of special and new in DS 1.4. Here are some references. The presentation will be uploaded, I hope so. And there you can also see some more detailed blog posts related to this topic. And please don't forget to evaluate. I'm done.